We're talking about packed project libraries, and we're going to do a deep dive on how to actually implement that in your software and make that work. So Christian, Sam, and myself are all going to talk about different things that we've done with packed project libraries and how to use them as a tool to make your software better and to make your software experience better for both you and for your customers. So my focus on this presentation is going to be actually automating software deployments using packed project libraries. So my name is Tim McClung. I know I've met a lot of you. I see a lot of familiar faces here. I've been doing LabVIEW for about 10 years now. All of my time has been in test and measurement systems. I've worked with TestDan, doing destructive testing and passive testing. Currently I do a little bit of both in production and in the non-production environment. I work at a company called Fight Corporation. We do engineered metal products for pressure relief, explosion protection, and we also do industrial fire control panels as well. So there's a lot of testing involved, and destructive testing obviously involved in metal products for pressure relief and for fire protection, and then also a lot of electronics testing for fire protection panels. My goal is that when you guys get done at the end of this 20 minutes, that you will have a good framework on how to implement an automatic software deployment in your own environment. How many people here do some form of automatic software deployment for the customers, whether that's internally or externally? Okay, you guys in the back, you guys up here, there. Who here would like to? Okay, hello target audience. So this is what I'm going to try to cover today. So I have built this, and I'm currently running this system that I'm going to show you in the next 20 minutes at our office. My job in the test and validation team at Fight Corporation, I'm the systems engineer, so I'm responsible for putting together the software and some of the hardware frameworks for our test systems. And we do both production and research and development testing at our company. And one of the systems I wrote was an automatic software deployment system written entirely in LabVIEW, and it's all based around using packed project libraries for the purpose of swapping in and out code. And like I said, at the end of this, I want you to have all of the information that you need to go out and build something similar to what I did, because it's really not that complicated. Once you understand the parts of it, the actual implementation is just sitting down and writing LabVIEW code, which is what we all like to do anyway. So hopefully this will get you well on your way to making that happen. So there's three parts to building an automatic software deployment system, and let me define that concept for a second. So when you talk about automatic software deployment, I'm talking about the process of a developer or a team of developers writing a update or a feature add to a body of already existing and deployed code and providing that change to the customer in either a fully automated or at least a semi-automated process, meaning that they don't need to be involved in the entire process of doing the update at the customer's machine. So they can create the software, provide it to some resource, and then that software resource does all the heavy lifting of moving the software and then getting it to the customer and then applying it to the customer's source code to make the updates happen. So I've already mentioned a little bit of the three parts that we're going to need to be able to know how to do to make this process work. And the first is the developer tools that you're going to need to have available as you're writing your software. And these will be the pieces of code that you write that you're going to use over and over and over again. Then you're going to have your logistics system. So this is going to be where you're actually storing all of your software masters. So when you're talking about packed project libraries, these are going to be where your master libraries are located. And then finally, your client software, which is the resources that your clients have along with the payload, the actual software that they're running. The software that's at the client side that does all the heavy lifting of looking at your software master, seeing if you've got any modifications, and then making the applications or applying those modifications to their source code so that they can get the updates, and then restarting the software and making all that happen. So why do we want to do this? Well, it makes life better for you. One, because you're not involved as much in the process of feature adds and bug fixes as you would be otherwise. So if somebody comes to you with a bug or they come to you with a needed feature add, you're going to be responsible for writing all that source code, building the change, and then making sure that change gets deployed to the customer. If we can get rid of as much of that process as possible, then you're back focusing on source code development as opposed to focusing on making sure those changes get applied to the customer. So this obviously improves the customer user experience because this is less emails that they have to send to you asking for changes, less communication required, less energy and effort on your part, and it makes the process of getting a customer a feature add or bug fix a lot smoother. And I have a demo that'll show you how that works here in just a little bit. So a few reasons why you should think about doing automatic software deployment. Again, it makes the experience with your customers better. It's more of a professional face for your software. It makes you look more in control of the process. And it gives you more time in development and less time in operations. So let's talk about the first part. The first part that I mentioned before is developer tools. You need to have some tools available to you that you're going to use over and over and over again as you're building your software. And those are how you build your Pack Project libraries, how you access your Pack Project libraries, and then how do you distribute those Pack Project libraries, the source code that you're going to need to make those things happen. So the code that I have up here at the top is actually the code that I use for my current builder. Now when you're working with Pack Project libraries, you're going to start to break out your code into different sections. Pack Project libraries by default are blocks of code or blocks of information that you can then share back and forth and share that source code to make your program run. But because you're going to start breaking those things apart, your build specifications are going to get more and more complicated. And it gets to the point where it makes a lot of sense to, instead of just using the standard build specification tool that's provided for you in the Project Explorer, to just go ahead and start building an automated build spec that'll do some of that work for you. If you're at this point, you're probably going to also be looking at using some form of a unit test framework, whether you're using one that's already provided for you that you've added your functionality onto, or what I'm doing here, you're using one that's actually built specifically for the framework that we use at our office. You're going to need to be able to do some unit testing. So you're going to need an automatic building tool that'll make all those things happen. And if you're looking at this code, what you're seeing here over on the side is that generate the library that's actually building that Pack Project library that's going to be the payload, the source code that we're going to give to our customer that has the feature adds or the updates. Those green classes in that block right there, that's the unit test framework that's going to go through the process of making sure that we haven't broken anything, all the features are working the way they're supposed to. Then we obviously go through and look at all the passes. Do we have a pass in every single instance of that unit test framework? As long as all of our tests pass, then we go back through the process of getting the new version number. So in this case, I use Subversion for my source control. We get the current version number of the source that you're working with, so whatever version number applies to that Pack Project library. We then apply that to the build number so that we have a track for our SVN number along with our source code, and then we rebuild the software, and then there at the very end, where it says push to master, we go ahead and take that Pack Project library, move it to our master location, and then our logistics system takes it on from there and gets it to the customer. Any questions on that so far, on what we're doing, on what's actually happening there? So this is all just how you would take a Pack Project library, build it, test it, make sure it works, get the information for your source code control to make sure that your revision or tying back to some form of source control, and then moving it to your master so that we can move on from there, which is the next thing we're going to talk about. Go ahead.
I need a question, but are you pushing out LabVIEW code to your customer, or are you pushing out
Pack Project libraries, PPLs.
Okay.
Yep, PPLs. So these are Pack libraries. So we'll talk about the executable side of it here in just a minute, but this is all PPLs. Everything is PPLs. Good question. All right, so next thing we need to be able to do is be able to access our code inside that Pack Project library once that software has been developed. So you're going to see this on the client side here in just a moment. But one of the things that Pack Project libraries make really easy is calling a VI from a Pack Project library. So if you know where that Pack Project library is located on your computer, you can see that VI over there says get exported file list. So if you know where the Pack Project library is on your computer, and you know the name of the VI, assuming that you have discrete names for VIs, or at least a unique enough name for a VI that you can search for it, you can then open up the list of all of the resources that are in that Pack Project library, find the VI that you want, get the file location of it, and then use that to do a dynamic launch. So this right here is that VI there. And then you just do a dynamic launch from that point. In this case, I'm doing a fire and wait. You can do a fire and forget, whatever you need. But because you have the tools that ship with LabVIEW to search Pack Project libraries for resources and then you have the tools to do dynamic launches in LabVIEW. All those things combined together allow you to load up a pack project library, find the VI that you want to launch, and then launch it from there. And you can launch 1 or you can launch 50 if you really need to. But generally the route that I've gone is that inside of my pack project library, I have a specific named VI, no matter what the tool is. I have a specific named VI that I launch that boots everything up from there at that point. So it's like launch VI or something to that effect. And I just call that, run that here, and then you're on your way. One of the things I've chosen to do is to not have any inputs into the connector pane. That's totally just a design decision that I went with. You don't have to go that route, but that's the route I went. All right, so the last part that you need to have put together is the deployment side of it. So you need a launch.exe, you need some kind of run once to get the MSI together. These would be all the resources that your customers are going to need the first time they install your software. So when you give them the installer with all the resources that they need on it, they're going to run that MSI just like they would run anything else. That's going to deploy all of their code, the current version of the pack project libraries, and what I call the Bootstrapper onto their machine. And then that'll get you started in the process where you can then start doing automatic software updates. I choose to keep a INI file that has all the information on what I need to know to launch that program. So if that program needs a certain VI, if that program needs to know that there's a pack project library in a specific location, I keep all that in an INI file that I deploy with that MSI at that point in time.
Can you explain what is run once?
I'm sorry?
What is run once?
Oh, good question. So the run once would be the tool that would handle any of the build-up or breakdowns that your .msi is not going to do for you. So if you're running a .msi, but then after that installers run, you need to move some files around or relocate things to different folder locations or do some modifications. And then at the end, when you do an uninstall, if you need to break some stuff down, remove things from the program data folders, that kind of thing, the run once you can run through your MSI. LabVIEW gives you the ability when you're setting up an MSI.
So it's a custom tool that you do.
Yeah, it's a custom tool that I use, and that just allows, the only reason why I say that is that usually you're going to have some .ini files or things that you need to move around when you're doing your MSIs, and run once is really good for that because you can just call them directly from the MSI when it's done, and then you can do the same thing on the uninstaller and it just does the reverse. So, good question. All right, so just a quick review of what we went over. The things you're going to need on the developer tool side, you're going to need a setup to be able to do automated builds with a unit test framework. You're going to need to be able to create and test your PPLs using dynamic VI launching, so you're going to need some kind of code to do dynamic VI launching. And then lastly, you're going to need an installer package with your pack project library and your Bootstrap that we're going to talk about here in just a minute. So now what do? So we've got all the software built. We've been able to give the MSI to the customer. They've installed the source code. And how are we going to actually start providing them updates and bug fixes from now on? And this comes to the logistics side of it. You need some kind of resource that's going to allow you to move the code from where you are to where your customer is. And this is what I call the code master. And the code master is just a location, and this can be whatever you want. If it's an intranet situation, if all your customers are internal, and I'm lucky in this situation that currently all my customers are internal, it can be an intranet location. If they're external, you can move to using like a GitHub or something to that effect, with a specific login that you could put inside your software. There's a lot of different options that are available to you, but it's a central location that you can put your binary source code that then your code master knows to go then and look at that location to see if there's been any changes. And that gives you that link from where you are when you upload the code to where they are and when they go look and see if there's been any modifications. The one thing I will say about this that you want to be careful on is that when you are building your projects, make sure to talk to IT about this part, because IT is going to have a huge impact on what resources you have available to over the life cycle of your project. So if you have a life cycle that's 5 years long, 10 years long, it's a good idea to talk to IT and say, here's the plan that I'm using to provide these resources to my customers. Can you make sure that these resources are available to me so that when I get 3 years into this project, all of a sudden my automatic update system doesn't work anymore, because then you're dead in the water. So the biggest part about this whole thing, what matters actually way less than where you put it, is that your IT is on board with you. So just have that conversation and save yourself some headaches. All right, so let's talk about the client side. So we talked about how we actually build the software, what the software resources we're going to need are, how we get that software to our customer. Now how does our customer actually pull that software down? This is where I coined a term that based upon motherboards, they call bootstrapping a motherboard when you turn the power on the motherboard. I call it this executable that we run at the client side that goes through all the work of finding the pack project libraries, checking to make sure the versions are correct, and doing any changes that need to be made, and then launching the program from there. I call it the bootstrapping VI. You can call it whatever you want. That's the term that I went with. And we want to be able to automate and update fully packed. We want to be able to automate packed project libraries and not run on a fully packed.exe. One of the tricky things about this is if you take all of your source code and you put it into an executable and you launch that executable, Windows is now reserving that executable memory space, so you can't go modify it on the hard drive now, right? It's locked. But if you are starting an executable and then that executable's sole job is to go find a packed project library, load it into memory, and then dynamically launch a VI from that packed project library, you can control when that packed project library moves into memory. If you've got control of that, then you can also control the ability to modify that packed project library, make edits to it before you bring it into memory, and then you're ready to roll. All that matters at that point is just going to check your code master, doing any copy pastes that need to be done, and then launching the VI dynamically from that point. And that's basically what this VI does. It's just a VI that goes and gets some INI information, figures out what packed project libraries are important, goes and looks at the code master, checks against what you currently have, and then launches the start VI dynamically. Yeah, go ahead.
If I understand right, it sounds like you're trying to make upgrades transparent to your end user, lots completely automated. Did you consider System Link as a means for you to push out updates to your end users?
Well, yeah, okay, so no, I didn't. The primary reason why is because the only resource I have available to me is LabVIEW right now. So, yeah, there are other tools that can do this, but if you want to do it strictly in LabVIEW, this is kind of an easy, stripped down way to make that happen. But there are absolutely other tools that can do this. Yeah, that's a great point.
Do you make your updates optional or is it required to update the next version?
So great question. So I would recommend prompting first. That would probably be the best way to go because often people don't like forced updates. Currently the way that I do it is, yeah, you know, I mean, there's a new feature and there won't be any new bugs in your source code or your software, so it'll be fine. What I do right now is if there is an update in any of the packed project libraries, I get the information in that packed project library, the new version number that's available, the one they're currently using, and then I just generate a prompt that says, here's all your packed project libraries, here's the current version, here's the new version, would you like to make that update? And then I have the ability also, this is mainly more for me than anybody else, but you can then silence or mute those checks for a week if you want to just mute the checks for a week and then come back later. So they have the ability to say yes, which goes through the copy paste and do all the editing. No, which just reboots and asks them again the next time we start the program. Or I have a mute for a week that'll just wait for a week and then ask me again after. So that's the way I went about doing it. It's pretty, it gives them everything they need to know without being, you know, your whole goal is to make this experience easier. So you want to give them the information, say, hey, there's a modification that's been made, but you're right, you don't want to just make some changes without knowing about it. So, good question. Okay, so a couple things worth knowing about how this actually gets implemented on the client side. So when you're building your .msi file that they're actually going to run, Windows provides a location which is project data. Who here uses project data folders when you're deploying your programs? Anybody? It's such a good thing to do. So what the whole purpose of the project data location is, it is a sandbox that you can create a location in project data that your project or your program can work inside to make modifications, edit files, use INI files, that kind of thing. Where in the program files directory, the x86 or program files directory is locked down really tight by Windows. You can't modify this location, but if you unlock the folder that you create here, you can modify that location. So what it means is if you put your PPLs and create a project data folder and put your PPLs in that folder, then you just modify them in that location because that location is now unlocked and you can make changes there which you couldn't originally make in program files. If you try to do this in program files, Windows is going to get very angry at you, so don't do it. Use project data, that's the right location. And you can make this, you can make those adds in your .msi when you're setting up your source folder settings. Okay, so this is the result. So this is the solution that I went with to do automatic software updates. And you've seen basically all this code up to this point. This is just everything all together. So this part over here, I have an INI file that I use to do, or a class that I do INI read writes with. And basically everything that's happening over here is just going to the INI file and finding the resources that I need to get together. So I go to the INI file, I say what pack project libraries do I need, what resources do I need, get all that information together. When I talked about that mute earlier, this is checking that mute so that if the user says don't bug me with this for a while, the mute just mutes the whole process. This BI here in the middle is going to do the comparisons. So once you get all the pack project libraries that you need, it loads up your current local versions of it, goes to the master, finds out what the master versions are, compares the two together, and then generates the prompt for them in the event that there needs to be a prompt. And then once that's all done, that BI right there, let's see if I can do this. That guy right there is does the actual find the BI that I want to launch in that pack project library, and then just does the dynamic launch from there. And then this, everything over here at this point is all just cleanup work when you're done. The reason why I did a fire and wait is that I could see when everything was clean, or everything was done running, and then I could do all the cleanup work over here and do an exit LabVIEW so that my pack project libraries didn't have to worry about doing that. That Bootstrapping would take care of it. But, let me see how I'm doing on time. So I'm going to try to be real quick and show you guys a demo of what this actually looks like on the customer side. So this is a demo of a calculator example that I wrote that shows you the whole process from beginning to end. And what you're going to see here is that we have a calculator that will do an add, and we have a calculator that will do a subtract. And the add function is going to be broken. And I'll show you the demo of that the add function is going to be broken. Then I'll show you running through the unit test and the auto builder, the update, the push to master, and then the redeploy. So right now it's running that calculate, and you can see that currently our math isn't working out right. So we'll check subtract. Let's just make sure subtract works correctly. Okay, our subtract seems to be working properly. So subtract isn't the problem, but add does appear to be a problem. So at this point, our customer will report that to the developer and say, hey, your add function's busted, go fix it. And then we would go in here and we'd run our unit test framework. Now this looks familiar, right? You guys saw this code just a little bit earlier. And we're actually going to run that source code. And what's going to happen is we're going to build a pack project library, run the unit test against the pack project library, get the information on the unit test, which is going to show up there in the results, on whether it's going to pass or fail. It's actually doing the build right now. There it is. Okay, so now you can see it here where it says C1. That addition function didn't pass, right? It failed. So it failed our unit test framework. How in the world this got past our UT the first time? I have no idea, but just suspension of disbelief. And now we're going to go and actually try to figure out where that's busted. So this is going to give you a little bit of insight into the framework I currently use. But here's our add function, and you can see there our add function is currently subtract. Oops. A little bit different. So we're going to change that to an add, and then we're going to go back and we're going to rerun everything. So first thing we're going to do is do an SVN update, make sure it hasn't been any modifications. Then we're going to do an SVN commit to push the code. So this will be the commit. We'll put in fixed the addition bug. And then we'll get our version number. So you see that version 475 is our SVN commit number. So remember that number here in just a second. And then we're going to go back and rerun this process. So what you'll see is that instead of it reporting a failure, it's going to ask us for the SVN number of the current version of the code that we're building this PPL on, because it passed. We'll put that 475 number in there so that we have a track back to our SVN, to our source code.
So why didn't you go to that?
What's that?
Why didn't you go to the version and take away this?
Because I haven't written that script yet. To be blunt. I would like it to do that someday, but I haven't gotten to that point yet. Oh, okay. So now it's going to show, it's going to rebuild, and then it'll show, okay, we got a pass, and we built, and it also has now, because this guy's right here, we've also pushed the source code to master. So we're going to send an email to our customer that says, what are you talking about? The some add function works just fine. Why don't you try the code again? And we'll pretend that nothing's wrong. No, actually, I didn't get an update, as you saw right there. And then now our add function works properly. And to the question earlier about the prompts, let me back up just a little bit here. Let's see if I can show that to you. So there's that, you see that right there. So there's the current release version, 475. It's got the tag for our SVN number on it. So that way, if they come back and ask us later and say, hey, there's something broken, or I'd like a feature add, you can say, what version number do you have? They can give you a version number, and then you know the SVN number tied directly to your source code. I find that to be helpful. So, anyways, this is how I implemented this function. There are a lot of other ways to do it, to do automatic updating. But if you want to do it strictly in LabVIEW, you can write this in a day-ish. And it's not terribly difficult, but it does become pretty handy when you start needing to push a lot of different versions to your customers. Any last questions before I give the guys the rest of the time, because I'm already over? Go ahead.
Did you look into using NIPM for this at all? Packaging up PPLs?
Actually, is that what you're going to talk about, Sam, is using a package manager? Yeah, he's going to cover package manager. No, I didn't. I haven't done this for package manager. My solution was simple because all of my customers are internal, so the process of moving PPLs around for me is a little bit easier. But yeah, if you're doing something that's a bit larger than what I'm doing, package manager might be a better route to go.
Have you heard or tried BLT?
I'm sorry?
Have you heard about or tried BLT? BLT, Build License Track.
I have not. No, I haven't heard about it.
Pretty much does all this with the click of a button.
Really?
Yeah.
It's BLT, you said?
Build License Track, BLT for LabVIEW. It's been there for 7 years.
Okay. All right. I'll take a look at it. Thank you. Thanks everybody for listening. Appreciate it.
So yes, I'm going to be talking about building PPLs for multiple platforms, in particular for Windows and Compact Rio. Who was not here for the previous presentation? Was Martin for? Okay, quite a lot of people. Okay, well, I'm not going to rehash their entire presentation because it was really good and quite detailed about building for Windows. But I think that it was recorded, so you might be able to catch some of that again. I'm going to go over some brief highlights. So here I have a library on Windows, and I'm creating a new packed library, and so this works when I run it on a computer, but when I tried presenting it the other day, it didn't work. Okay, well, this video would have shown that you can start by setting some directory here, and I've chosen a shared directory for all of my PPLs. Then you go to source files, and you choose your source library. Then you go to set this shared directory, and I choose to exclude dependent packed libraries from the advanced tab here. And then on the preview, you just see my library.lblibp will be generated, and you can click build, or you can click OK, and then right-click and choose build from your build specification. So that would be how you generally do it if you had one library and you didn't want to automate anything. When you want to start doing this on two targets, you have a little bit more trouble, because now if you don't have any dependencies, you're kind of okay. You can load them both in the same project, you can build them both in the same project. It will quite happily do that for you on two different targets. As soon as you have some dependency, like here I have b.lblib, and it contains a VI that has det on my library. Here I can see that my library, this is the Windows copy, and this is the Rio copy. Both of them are not loaded, and when I try and build it, it tells me I can't load a library built for a different target. And this will completely block my ability to build them in the same project file. The preview, when I try and build it, looks something like this, and it says that this VI was broken. So Mark and Ford talked about this before, but basically the solution is to always load your PPLs from some specific relative path. And so in my case, I have something like this, and I'm always looking to load my PPLs from some shared directory up here. And I store a copy of all of my PPLs built for different targets. So I have debug 32, 64, release 32, 64, and then Creo variations on the same. And this list of PPLs is a full collection of all of my PPLs built for each of these different configurations.
Does this mean in order to build, you have to have 4 copies of it on your...
No, so if you only wanted to do, for example, debug copies, you could just build debug, or you could just build release, whatever. I found it convenient to build a full set of all of my targets, and then if I want to change, I can just copy and paste from different places. Here I have an additional copy for Creo. This is kind of similar. I use this directory for when I'm building a real-time executable on Windows, because then you do need a different path to load the same library for 2 targets. So when I want to build my next debug 32 library, I copy all of the libraries that I need out of here into here, and then I can load those how I expect to. When I've finished building it, I just revert back to whatever I previously had in that directory. I will point out that you could use symbolic links to avoid all of your copy and pasting. The problem that I have here is that I have a list of PBLs, and I can't easily symbolically link to 20 PBLs. I'd have to do it one at a time. And if I had a different directory here, maybe a current, then I could make a symbolic link to the appropriate directory that contains those PBLs. Okay, so that was the non-automated way to do this. Once you want to start doing that a little bit more automatically, like Tim was talking about, you can use the application builder API, and I think that he showed some secondary code that I guess probably used that. But
Probably functions similarly, but don't use that specific API.
okay, well, LabVIEW ships with an application builder API, I think probably in the professional edition. I'm looking at Chris Billion at the back, but okay, some versions of LabVIEW, definitely including the professional version, ship with the application builder API. And this has classes to build PPLs and real-time PPLs. And so you can build this build specification programmatically, and you can call it from a command line. I'm using the GCLI command line from Wiresmith. NI also has a command line interface that you can use. And so my command line inputs are the path to the library that I want to build, the directory that I want to build into, and for me this is LabVIEW sources/PPLs, a list of options, and this is always the same length list of options, so it's quite easy to parse, and then a variable length list of all of the LVLibP files that I need to be able to build my library, the dependencies of my newly built library. This is what I call from the command line. And so first I'm going to pass my command line inputs. And that looks something like this. I have an array of strings, and I convert them into LabVIEW file types that I find more useful, paths. Here I'm going to make some command line calls using a system exec node to get Git to give me a version number. Here I'm going to increment the version number based on the type of build that I want. So my commit messages can distinguish between major, minor, and patch builds, and they'll increment a different value in the version. At the bottom here, I have some code that just checks that the variable length list of dependencies actually do all end in .lvlibp. This shouldn't be a requirement, but when I first did this with NIWeek, I had some inconsistent grep that would occasionally throw in VI files to this list. You probably don't need that. This then moves on with my CLI inputs. I'm displaying them here so I can just check when I'm running it on my computer. And I go into a build VI here. And this carries out a series of steps. So before I call this VI, I've already gotten a version number from Git. And then I go ahead and create a new project, a new LabVIEW project from a template. So this repository containing the builder code has 2 empty projects. One of them is completely empty, like a blank project, and the other contains just my Creo target. And then in my second VI, I'm going to get the reference to that target item so that I can add libraries to it. So this is all just LabVIEW scripting code. It's not particularly unusual. Here, I can choose to load additional build configuration items out of the source repository. I'm not going to talk about that at all, but if you have some additional requirements on a repository by repository basis, you can specify. Oh. And here, I'm taking a copy of all of the PPLs that I need and moving them into my build directory and adding them to the correct library, the new project. So at this point, I now have my LabVIEW file in my project, and all of the PPLs that I need to build are already available for it, the dependencies. Then I go and initialize the build spec. So this is what we saw in the first slide. You're setting the name of the PPL, the destination directory. You're choosing to exclude dependent packed project libraries. Any other things you want to put there, copyrights, version number, information, that kind of thing, you can put in here. And then I just call build. And once I'm done, it gives me the path to the PPL that I've built. And I install it, which really just means copy and paste it into the directory where it's supposed to go. Finally, I clean up any temporary files and make sure that my starting directory was the same state as what I began with. Now that's all fine, but my command line is kind of like this. And if you had to type that, you'd probably make a mistake occasionally, and it's quite annoying. And this only has one dependency. If I had more than one dependency, I'd have a series of quoted arguments, and it just gets longer and longer. Obviously, I don't want to do that. I expect none of you would want to do that either. So my first attempt at trying to avoid typing this all out was to use NIWeek. This has some nice benefits. It's free, it's widely available. Almost every Linux system will have it installed. You can install it on Windows too. And it's a tool with a lot of history handling dependency chains. So you don't need to write a lot of code to say build this, then build this, then build that. You just say build this, and it will work out what other things it needs, provided you tell it what depends on what. So I produced some small files, and I called them .mk to allow me to search for them. So this would be af_messages-ppl.mk, where the library is .lvlib. And I load these files and pass this list, and then I say those are my list of dependencies. If I want to build other things that my repositories need, I can do that too. So make is very extensible. I can build C language DLLs. I can make sure that they're packaged with my PPLs, things like that. And I only need one rule. This is 3 lines or something to build all of my PPLs. The problem is that this has quite a lot of escaping characters. And these functions here are related to escaping white space. Which brings me to basically the reason why you should not use NIWeek on Windows. Which is, with make, everything's a string, and it tokenizes based on white space. So if you have spaces in your file names, what you get is something like this. You think, oh, I'll put it inside quotes, that's going to be great. And then what make reads is this, and then this, and then this. And then you have a list of 3 files, none of which exist on your disk. And you can get around this with those escaping functions, but it makes it quite hard to read your make file, because now you're like, oh, let me try and debug this, let me print it to the output. When it prints, did it include all of the escaping characters, or were some of those removed when I printed? Additionally, make is timestamp based. When you delete and reclone a repository, even if nothing changes, it will rebuild. For some people, that might be ideal. Maybe you really want to always rebuild everything. But here you don't really have a choice. So I ran that quite happily on my desktop for a while, but when I moved to Jenkins, getting Windows to call Windows subsystem Linux to call make to call this became a bit too much trouble. And so I started looking up alternatives, and then I picked up SCOMS, which is a Python-based system that basically does the same thing as make. And so as a Python-based system, it will handle paths, it will handle quoted strings, it has cross-platform support. You can scan for applications like your LabVIEW CLI on your path, your Windows path. generally you're going to have an easier time when you're using different platforms. And to do my builds, I used a single sconstruct file. This is basically a make file, but for scons. And I didn't change any of my .mk files, so I'm just passing the same list of dependencies. You can choose to detect changes based on timestamp, in which case it behaves exactly like make, or based on a hash of the source code, or you can write your own Python code to decide if something has changed or not. And debugging becomes simpler because you can print things and be reasonably confident about what's coming out. You can define whatever you want using Python code. And here I've written a builder, which is the name of a class that they have to describe how you basically generate a command line for some type of file. And here I'm just saying, call this with this LabVIEW version, do these flags, dash dash, and then all of those arguments that we already saw in my past CLI input. In principle, you can define scanners to check for dependencies of your source. In NXG, this might be more useful because you can pass your source code a little bit more easily. In current generation LabVIEW, it's a little bit tricky to programmatically pass without opening a project and loading through LabVIEW your dependency list. So I use directory structure to determine my dependencies. I found that that was perfectly fine for me. If you are concerned about that, you could programmatically and carefully go through all of your VIs and libraries and so on. But I don't think it would be a terribly easy task. Some minor disadvantages are that if you look at large-scale scaling, scons is slower than make. This has affected me not at all because I don't need to call so many external tools. I can use a lot more internally. And I don't need to compile 100,000 files. I have 20 PPLs. Even if I had 100 PPLs, I'm probably not concerned about 1 second versus 1.5 seconds. Conceptually, it's a bit more complicated. Now I have various different classes, and I've defined some of these. Avoiding rebuilds uses a database file that they create. If you routinely wipe your workspace before you start building anything, then you will lose this file, and then you'll rebuild everything. If you're routinely wiping your workspace, that's probably what you want, so it's not such a big problem. But if you want to wipe all of your workspace but not rebuild things that you didn't change, you would need to make a bit of an effort to copy that out of your workspace first and then restore it afterwards. Python is more complicated than just saying this is a lot of strings, but Python has a lot of things that can help you. Yeah, okay. So, has anyone got questions so far? Or? No? Yeah, in conclusion, I would like to reiterate that building for multiple targets is easier if you use a single directory to store all of your PBLs. Martin Ford showed some clever ways to do this with a hierarchy of directories, but they still built to one shared location. Scripting with a template is much easier than scripting from scratch. So if you have multiple targets, just define one project per target, and then you won't need to generate a new target every time. Listing your direct PPL dependencies makes it much easier to scan for that list, but you don't need to list your nested PPL dependencies. So if I depend on something that depends on something else, I only need to list the things that I care about, not the things that those things care about. And scons or similar tools will allow you to generate a command line with, in this case, an appropriate builder. And here you can see Jenkins being triggered. You can run unit tests if you'd like, and you can embed a version with scripting. This is especially useful for real-time Linux, where you can't use the file properties in the same way that you might on Windows. So the file version that you choose in the build specification, it's visible nicely on Windows, but it's lost entirely on Linux. So creating a VI that just outputs that data is useful, and then you can run it on whichever platform you want. That might be useful if you wanted to update for different targets. Here's some summary of me running this up. Observant viewers might notice that my run tests took about 300 milliseconds. So that would be because there weren't any. Does anyone have questions? Yes?
What's your experience with custom FPGA codes?
I haven't tried building FPGA code for like automated builds. Like I have one FPGA project and I build it manually.
Okay, it's separately.
Right, right. Yeah.
Have you considered scripting the listing of your direct PPL dependencies?
Well, so I think that somewhere you would need to list your dependencies somewhere, right? It would be possible, for example, to output the list of dependencies from the project, the previous build, but then if I change some code, I don't update that. So I would need to maybe write a project provider or something for like on close.
No, you could input the path of your library, for example, and programmatically check all the dependencies, and for each of the dependency, check the colors and really see if the colors is your source library.
So the problem there is that if I open a library in my project file, for example, and then I check the dependencies list, I can get a list of all of the PPLs. But if I'm building for a target other than the one that they happen to be currently referencing, they'll all be broken, and I don't think that the dependencies list plays very friendlily. It might be possible if I like reloaded repeatedly.
We will talk about that because I'm working on this.
Okay. Yeah. Great. Yes. Well, I think I'm more or less out of time. Here is some code for scripting VIs. Here is a possible implementation for unit testing. And here is some code to allow you to unit test both the source code and the built project library that Matthias gave me on the forum about a year ago. Yes, that was all of the extra stuff. So, great. No, that was perfect. Okay, thank you.
All right, we got about 10 minutes, so we'll make this quick. Sam Roundy. I'm in an open relationship with 4 different companies right now. Basically what that means is I'll just work for money, so I consult a lot. If you've ever been on the test stand forums, I go by username Jigawax. So agenda's pretty short. Overview of Package Manager, what it is, what's the CLI, command line interface, and then what you can do with that command line interface, basically. So when we're developing, we have to get our IP to other people. And when we do that, we need to decide who needs it and what it is. So if we need to get our IP to other developers, there's a lot of ways to do that. There's source code control, there's VI Package Manager. How many of you use VI Package Manager? How many of you use GPM? Yes, one in the back. GPM is a tool from MGI. Yeah, I highly recommend it. I played around with it. It's a great tool for basically installing to your project location. So, great tool. These are good tools for getting your source code to other developers. However, when we need to distribute our binaries or our packaged up or ready to run code to our customers, we call that deployment, at least I do. There's a couple of options. I've heard of people using VI Package Manager for that as well. You can do the traditional installer way, MSIs, and set up .exe, install .exe, whatever those are. You can copy and paste. I have seen that practice used a lot, unfortunately. And then you can use NI Package Manager. It's free. It's great for component-based applications, plugin type-based applications, big test stand component. Big test stand user here. And test stand, if you're familiar, is a very component-based application. And it is built on Debian 2.0 packaging. So it is built on a existing Linux type packaging system. Here's kind of a quick overview. How many of you have used NI Package Manager before? Oh, so see. So basically, you have the application, you have package files, you have feeds, and then you have the CLI. with a feed, you basically have 3 files. You have a packages file, which is all of the information about how to distribute that package, or each of the packages. And then you have packages.stamps, which are relative paths to the location of all of your NIPKG files. And then you have packages.gz, which is a binary, which I still haven't quite figured out, which is generated by the command line interface. So it contains a bunch of other information. There is a feed manager that Alan wrote, sitting back there. You can go download it, and it's free, and it goes through the command line interface that I will show. He also has a LabVIEW API that he uses as well. So here's the command line interface. Basically, package manager is 64-bit. That does not mean that you cannot distribute 32-bit binaries. You can, and we do all the time. But so it will be installed to the 64-bit location on your 64-bit machine, and you have to have a 64-bit machine. And if you go to this location, program files, national list, NI package manager, NIPKG.exe is the, yes?
Small clarification. Starting with NFDN 19.0, it actually has 32-bit support.
Okay, so you guys finally got that in there.
Yep.
Good job. Thank you. So apparently there's a 32-bit version. Hopefully you don't have to use that in your own. So if you're in aerospace and defense like I am, then you probably do want some machine. So you can use this CLI to create a ton of tools. I'll show you one that we've created in a minute. Here, if you type help, NIPKG help, it will show you everything that you can do, just like if you're familiar with command, DOS-based or even Linux-based type stuff. Pretty common thing to do there. I'm going to highlight a few of the commands that I use a lot. The install one is one that we use a lot because we don't like feeds. Because the problem with feeds is that the end user likes to do things on their machine that we don't like them to do. And so we just create our own installer, and I'll show kind of how that works in a minute. The allow downgrade feature is a big one for us because sometimes we will throw a bunch of beta packages on there, test it out, and then we want to go back to the released package or released versions and start running production again with those. And so that's huge for us. And then there's a whole bunch of other arguments that you can pass to make it cool. I did find out as I was doing all of this that Windows does restrict command line text to this many characters. So I had to like chunk my things up as I was doing. What's that?
That's going away in 2 months, the command line restriction.
Really?
Yeah.
Oh. Too bad we're about 10 years behind. Where I work. So, pack is a great one. You can create your own packages. There's a lot of feed ones if you're into feeds. Kind of have to be sometimes with package management. This creates a package. Sort of. You can give it to them, and they can run it if they have package manager installed on their machine. Or you can give them a feed, which is a group of packages in those 3 files that I talked about earlier. And they can subscribe to that feed, and then they can install anything from that feed that they want on their computer.
Afterwards,
not automatically, they have to manually do it. But you can create scripting tools that they can run a button and it will install everything from their feed. So that's what SystemLink does.
What's the advantage of this additional management for reading setup.exe code?
What's the question?
The question is, what's the advantage of Package Manager over a traditional setup.exe? It is for component-based applications. So this is the API that Alan created as well for LabVIEW. Go download that and play with it. This is the package builder. What time are we at? I want to keep you guys. Oh, we have 5 minutes. This is a package builder that one of our co-ops created that we use to create packages when we're quick and dirty and we don't want to go through LabVIEW. Because you can just throw any file in there, tell it where to put it, and then build your package. I'm going to get to your question in a minute. So basically, at L3 Technologies, we have 500 machines that we have to manage that are running test code. We have framework code for test in, and then we have a hardware abstraction layer with like probably about 70 different instrument types inside of our hardware abstraction layer. And so at any point, we could be distributing about 150 different packages to one of these machines. And so this is where packages come in handy, is that I don't have to take a 4-hour build time to fix one little weight or one little part of my code. I can just create that package, throw it into a feed, and then they can subscribe to that feed and grab that package, and it will only show the one that's different in Package Manager for them. And then you can create a feed for this kind of test PC. Like we have a bunch of copies of our test computers, and so they all subscribe to the same feed, and then they can all look exactly alike on the floor. Right, so that's one of the advantages as well. Our build times are minutes. Like, if it's over like 5 minutes, we don't like
The
it.
main advantage, you don't need to rebuild the entire
Correct.
application.
Yeah.
Only part of it.
Yep.
And that part rebuilt can be distributed internally smaller.
Yeah, so we use PPLs, as these two talked about, and we have plugin architectures. And when one of those goes bad, or we need to add functionality or something like that, well, code doesn't go bad. When they find the bad parts of the code, we go rebuild it, just throw it out there, and we only have to validate that one little piece. This is really good for medical applications we found as well, because in the medical world, you have to validate before you can throw it, before you can make it live. And this is really good because we can prove to the QA team that only this one little package changed, so that's all you need to look at on this computer.
So that package is a piece of runnable code, not the source code.
It's a project library, usually is what it is, or sequence files.
From the point of view of the user,
Correct.
it is a runnable code, not
Yep.
the source code.
You can't distribute source.
Correct, it's a binary. Say that again, Chris?
You can distribute source.
You can distribute source through this. I don't recommend it.
The main purpose
Yes.
is to break the runnable code.
Yeah, correct. So you modularize your code, and then you distribute it as a bunch of modules, essentially. Questions? Yeah, we do. We distribute. Almost half of our packages are just single sequence files. So, like I said, we'll distribute 150, 200 packages to a single machine. And a lot of those will be just this abstraction layer, which I'm going to talk about on Thursday in my testing class. So I can afterwards. I will, if you want. One thing that we found is feeds were very painful for us because, one, they take a lot more time to build, and then you have to register them on the deployed computer, and then once they're registered on the deployed computer, you have to run through and execute them manually, or you can create a tool to do that. So what we did is we basically have where we store all of our packages. We created this, what we call a package repo builder, and then we'll distribute all of the packages into this like zipped up file, and then we have an installer that takes that and just runs through the command line interface and installs them all on the machine. And it runs super, super fast, and it's like 100 times faster than feeds for us. And I can see Alan back there smiling. And so it runs way faster, and we can set up like probably 150 packages in like less than a minute. So
Sam, it sounds like your use case is, I want to distribute onto a computer the entire contents of a repo. You want it to be mirrored?
not repo in a sense of source code repo.
Right, but feed, excuse me, a feed.
A feed essentially, yeah.
Okay, cool.
But we call it a package repo. So the one thing so on my next slide, what will happen is then we'll come out with a Rev 2 of package B, and we want to distribute that So we just so now we have 2 versions of this repo, and I can push one out to the machine, and then this is where debugging and different things comes in handy, or beta testing or things like that. And so I'll throw that beta test package over there, run it, and then all I have to do is run that repo installer and push all those packages onto the machine real quickly. And then it will set that machine back to the exact state that it was before with other packages. Yeah.
I'm sorry, I'm stuck on the left. Did you consider making an NI package that lists the other NI packages that you want to install?
You mean for dependencies?
Yeah.
Yeah, we did. Dependencies were also a pain,
Okay.
so we didn't. We can talk
I'm
afterwards.
curious.
The problem is with test stand, with dependencies, is with the test stand components, because of the nature of test stand, you can't have 2 files named the same thing in the same place on Windows. Imagine that. And so basically, because if you want a front-end callback package and a different kind of front-end callback package, and then you have more of those, the dependencies gets crazy, and now you have to go back to all the previous packages and create dependencies. It just causes a cyclical mess. So yeah, we just abandoned dependencies for now. So until we got a system link. Package Builder 19.0 is out, released. I'm excited to try this. I haven't played with it a lot. This should alleviate some of our pain. So I hope to play with that and look at that. But that's it. There's a whole bunch of other stuff. So questions, come feel free to ask me.